So my name is Scott Lee. I've been working in Perl for 20 plus years. I've been interested in testing issues since before that. Done a fair amount of consulting work and seen a lot of companies and seen a lot of good testing and a lot of not so good testing and tried to observe, well, what's the difference and what makes good testing and what makes bad testing and tried to figure out some patterns and so that's what I'm going to talk about here is how do you write testable code? How do you make that work? How do you make your code so that it can be easily tested? So first of all, I'd like to say that writing tests is easy. It really isn't hard to write a test as long as the code is testable. So what does that mean? What makes code testable? How is it different from code that's hard to test? And so that's something I've been focusing on for many years, trying to understand that is what makes code easy or hard to test. And another question is why? I mean, hey, you know, we're a bunch of geeks. We like writing code. Writing tests is just kind of an annoyance. Is it really that important? I mean, is it important to even document your code? I mean, really, it just kind of gets in the way. So why do you do this? I mean, everybody tells us it's a good thing. Why do we do this? Well, initially, having a good test suite gives you confidence that your implementation is right. You know, when you're first writing the code, the initial benefit of that is, hey, I know that my code passes all these tests. I have a fair level of confidence that it's right. Now, there's probably still some bugs in it, but maybe it's not as buggy as had I not written those tests. So that's the initial benefit. Then the ongoing benefit is that you come back later and you or someone else needs to fix a bug. And how many of you have fixed a bug and in the process introduced another bug? Let's see some hands. Okay. And all the hands that aren't up, well, they should be up because we've all done that. I mean, come on. You go fix a bug and you end up introducing a new bug in the process. But if you have a good test suite, maybe that bug will get caught. Not all the time, but if it's a good test suite, there's a good chance that that secondary bug doesn't make it into production because it's caught right up front. Same thing if you're adding new features or just re-implementing, maybe you're trying to make some performance improvements or whatever, and you're making some changes to the code. Same thing. You're adding this new feature, and in the process, you introduce 5 new bugs. Well, with a good test suite, you're probably going to catch at least some, if not all of those up front. So those are the ongoing benefits. And long term, if you look at the benefits over the life of that software of having the test suite written quality software or quality testing up front, it actually saves time over the life of the product. Because of the time it takes, it saves you in the process of fixing bugs, and adding new features and whatever. The net effect is that it's going to actually save you time. And my personal opinion is that it probably saves you time even up front. Even just that initial benefit of having that confidence up front allows me to actually write the software faster. In my opinion, it's actually faster to write the software up front by doing the testing along with it. So that's what we're going to talk about here. So the next important concept here is black box versus white box. And you probably all know what black box versus white box is, but black box basically means that it's a test written from the point of view of someone that doesn't understand how the code works, just how to use the code. So you understand the interface, you know what the inputs are, what the outputs are supposed to be, and you write a test to verify that that happens. White box testing is kind of the other side. It's written from the point of view of someone that understands the internals of the code. How does the code work? What algorithms are using, what kind of loops are going on, what kind of stuff's happening behind the scenes, and you test things that wouldn't be obvious to the black box tester because they don't understand how the thing works. So the white box testing is important to catch those kinds of bugs, but as we'll see, these are two separate things and you need to separate them, and we'll talk more about that later. So when you're re-implementing something, you're fixing a bug, you're adding a new feature, what happens if a white box test fails? Is that kind of expected? You're changing the algorithm and this white box test doesn't pass anymore. Well, that's expected. You just expect that to happen. You go fix the white box test. But what if the black box test fails? What does that mean? That means you've probably introduced a bug that's going to cause backward compatibility problems. Because the black box test verifies that your interface has not changed, that you've not changed the meanings of the inputs or the kind of output that you produce. So when you're fixing a bug or adding a new feature or whatever, if a black box test fails, that's a red flag that you've probably got a problem. Unless you're intending to introduce a change that you know is backward compatible, you should not have any black box tests fail. So we're all programmers. We probably don't have a testing group. Now, some of you may have a testing group that writes your black box test for you, but most of the time you end up having to write your own black box tests. Well, gee, I wrote this code. I know how it works inside. How can I write a black box test from the point of view that somebody that doesn't understand how it works? That's difficult. But it's important, because having those black box tests tells you when you've broken backward compatibility. It's okay to break a white box test. It's not okay to break the black box test. So they have to be separate. You have to make sure that you keep them distinct. And so how do you do that? So that's one of the things we're going to talk about here is how a process for building a black box test suite, even though you understand the code. And the key to it is documentation. So if you write documentation that defines your interface, what are the inputs, what are the outputs, what exceptions, all the side effects, make sure you thoroughly document exactly what is the interface to your software. Then you take that documentation and you go through and you make a checklist of every claim that you make in that documentation. If you say that, well, this needs to be an integer in such and such range and the output's going to be this, every one of those claims that you make needs to go on a checklist, and that checklist drives your black box test. So that's how you do it. You simply write the documentation explaining how your software works from the point of view of the user. You're not explaining how it does it. I use this loop. No, you don't say that. You say, here's how you use it. Here's how you call it. Here's what you'll get back from it. And from that documentation, you make your checklist that then drives the black box. And so for every one of those items in the checklist, you write a test in the black box to verify that that is true. So that's how you create a black box test, even though you know how the thing is implemented inside. And make sure that your black box test isn't testing white box items. Okay, so one of the things that I like to do is to keep the documentation separate, because remember, the user documentation that drives your checklist, which drives the black box, you also need to document how the thing works, the implementation, the details. And so the way I like to separate that is pod is the definition, is the documentation for the user. Comments are the documentation for someone that's working on your code. So the white box related kinds of things are in comments. The pod is exclusively user documentation. So I never put implementation details in my pod. Those go in comments in the code, because I really don't even want my users to know what the implementation is, because that may change. I may decide later that, oh, this doesn't perform well and I need to change my algorithm inside. As long as I don't change my interface, that's okay. I want to be able to change that internal implementation and not affect my users, because I don't want them to even know what that is, so that they don't depend on those things. So I have what I call the interface contract. So this pod, the documentation of your interface, is really a contract that you have with your user that says, if you give me this, I guarantee I will give you that. Okay? There's no implementation detail here. I'm not telling you how I'm going to give that to you, but this is what I will give you. And I write that very precisely and make sure that I'm thorough. I cover all the inputs, all the side effects. If I'm returning a list, do I guarantee it to be in any particular order? all the details that the user needs to know about how to use my software. I enumerate all those claims that I make. Those then drive my test. So this improves my documentation. Obviously, if I have to be that thorough in writing the documentation, I'm going to have better documentation. I'm going to have better tests as a result of it because that documentation is now driving my tests. And it will also make my code better. So the user should not be reading my code. My pod should be sufficient for them to know how to use my module or whatever it is. They should not be looking at my code. I really don't want them to look at my code. Why do I not want them to look at the code? What is the disadvantage of your user looking at your code? Anybody? Pardon? Now they know the implementation, and they may depend on something that I did in that implementation that I didn't intend to be a permanent thing. So, yeah.
I was going to say it breaks the abstraction.
Breaks the abstraction, right. You really don't want them to understand the implementation because that may change. Okay? So you want to keep that separate. Your comments are your internal documentation for someone working on the code. It's right there next to the code. That's the appropriate place for those comments. The pod is for the user. Okay? So you don't want your user looking at your code, and if you don't write sufficient pod, you're going to force them to go look at your code to figure out how to use your code, and that's bad. You don't want that. So I've basically already covered this, is that you're going to force the user to basically use undocumented or unintended features. So for example, simple example is you return this list, and because of your implementation, you return it in some particular order, and the user is looking at your code and they see, oh, you returned this in this order, that's great, that's perfect, that's the order I need, and they depend on that order. But you didn't intend that. And then a couple of months later, you go fix a bug, and you change the way you generate that list, and now it comes out in a different order, and you've broken their code. Because they're depending on a feature that you didn't document, you didn't intend to be a feature, but they're depending on it because they looked at your code. So this is why you don't want users having to resort to your source code. Your documentation needs to be sufficient. So we touched on this earlier, but when you're fixing bugs, adding new features, it's okay to break the white box test and you go fix the test to match the new implementation. But if a black box test fails, that's a red flag. You probably have a problem. You don't want your black box tests to fail. You should write them up front, and you should never change those tests. Now, you may write new black box tests because of new features you've added, but you should not be changing the existing black box tests. This is how you guarantee backward compatibility. So when do you write your tests and documentation? Maybe you write all of your documentation and tests up front. I do that sometimes. Not that often. More often it's more of a case of kind of intermingled with the code. I'll write a little code, I'll write a little bit of documentation and test, write some more code, kind of back and forth. But if you're going to write the tests and the documentation, especially if you're going to write the tests after the code, make sure it's soon after. And while you're writing the code, assuming you're writing it before the test, think about your test while you're writing the code. Okay, now, if there's one concept that you walk away with here, this is it. This is the most important thing in my presentation. While you're writing the code, assuming you're doing it before the test, while you're writing that code, think about how you're going to test it. If you just do that, you'll find that you will discover things on your own that, oh, gee, if I do this, that's going to be really hard to test. And you'll end up writing it a different way that's easier to test. Okay, now, the second half of the presentation, I'm going to talk about a lot of different techniques of how to make your code more testable. But I'll tell you, if you just do this one thing, think about your test as you're writing the code, most of these things will just become obvious to you. You'll discover these things on your own. I've discovered most of them on my own before I read any academic papers discussing various techniques. A lot of this stuff I just discovered on my own because it was obvious to me, because I was thinking about how I'm going to test this and realizing if I do this, this is going to be awful. I'm going to have to do these convoluted things in my test. Oh, I can pull this out and put it over here, and now it becomes more testable. So that's the number one concept. Think about your tests as you're writing that code. We know that when we write code, there's bugs in there. Tests, well, they're just code. So our tests are going to have bugs. We need to test our tests. Think about that. So what I like to do is go in and, for example, comment a line out from my code and verify that now the test fails, or add something extra in there to cause it to do something a little bit wrong, and verify that, yes, that test fails. And I make sure that every single test fails. Okay, so for example, if you write your tests up front before you've written the code, they better fail. If you write your test before the code and it doesn't fail, you've done something wrong. Okay, think about that. Your tests need to fail. You need to verify that they will fail under the right conditions. And it's best if you, once you finish the project, go through and make sure that you can make every single test fail. Go through and comment something out, add something, whatever it takes to cause that test to now fail, and verify that it actually does catch that and fail. Okay, so make sure your tests are functional and correct. Okay, so I think you can see from this that a good test suite, your documentation, and your code, the quality of those three are really very much intertangled. You can't really write good code without having good documentation and good tests. They're very much intertangled. Okay, so the next thing I want to talk about is some techniques, show you some actual examples of things that will make your testing easier, because your code is easier and more testable. And I did some research on the web to try to come up with a checklist to make sure I was covering everything, and I hate this slide. There's a lot of buzzwords up there, a lot of stuff. Law of Demeter, Liskov substitution principle. What does this mean? I mean, I'm not saying these are bad ideas. If you're interested in testing and you want to make your code more testable, download my presentation from the conference website, go to this list. Here's a checklist of stuff you should go Google and read about these things. There's excellent papers on the web about all these topics. I strongly recommend that you read those documents, those discussions of these topics. They're great, but I like to keep it simple. So I'm going to discuss not all, but many of these concepts, but in a little bit nicer, simpler format. So my first principle is keep it simple. If you're having to, for example, go write some tests for somebody else's code, and you run into this 1,000-line routine, how easy is that going to be to write a test for that 1,000-line routine versus maybe that same algorithm but broken up into a whole bunch of smaller routines, which is going to be easier to test? Maybe the 1,000-line thing was easier to write. Well, maybe it wasn't, but the smaller multiple modules or functions or methods is going to be easier to test because it's broken down into smaller pieces that you can get in and test each one individually. Okay, so that's first principle is just keep it simple. And continuing with that idea of keeping it simple, split out complex decision making. So let's say you find in this 1,000-line routine, this block of several lines of a bunch of loops and nested ifs and whatever. It's a complex structure that all it really does is it takes some input and it sets one variable. And then the next thing in the 1,000-line routine is to use that variable to do whatever with it. What if you took that block of code out and made it a separate method or a separate function? You hand it the input and it hands you back a number or a string or whatever, simple output. Would it be easier to test that as a separate function or method, or would it be easier to test it embedded within that 1,000 lines? Well, that's pretty obvious. It'd be easier if it was separated. So if you're faced with this 1,000-line routine, start looking for these things that, oh, here's the decision, it's nice and it's isolated, I can just pick that up and I can move it over here into another function. And now I can write a test for it. Maybe I can even determine that there's a finite number of possible inputs to it, and I can do an exhaustive test and test every possible input, and then I'm really confident that it's right. I couldn't do that while it's embedded within the 1,000-line routine, because I can't directly access it and feed it the input. And I can't even see the output that it produced because it's writing to some variable that's then later used in the 1,000 lines, and I don't ever get that access to that variable from my test. So pulling it out makes that easier. So leave the code a little bit better than it was. If you're faced with one of these 1,000-line routines or any other problem that you run into, try to fix it. Try to make the code a little bit better than when you got there. So here's an example. We have a routine that processes the file. Now, two ways I could handle this. I could, in the first example, I could pass the path of that file. Maybe this is a config file or some kind of a file that we're going to process. Or I could pass the contents of the file. Does it matter? Would one be easier to test than the other? In the second case, to test this, I simply hand it my test data. In the first case, I can't just hand it the test data. I have to take that test data and I have to open a file, write it to the file, close the file, hand the path to it, to the routine, and at the end I've got to delete it, or I've got to use one of the modules on CPAN to automatically clean up my temporary files. It's not a great deal of work, but it's a little bit harder. Now, sometimes the right answer here is, yes, I really need to pass the path of the file because that's just what the user needs. But think about it. Does it make sense that maybe I could just pass the contents of the file and let the user read the file and just hand it to me? It would be easier to test that way, and if that's a reasonable decision, then that's what you should do. So don't just blindly assume that passing the path is always the right answer. Sometimes it isn't. Here's another one. This routine determines whether today is a holiday. The second one does the same thing, but you pass it the date. Which is easier to test? Yeah, on that first one, what am I going to go change the system clock to test this thing? That just doesn't work. So what we're doing here is we're avoiding external resources. That system clock is the external resource that we want to avoid. We don't want our business logic, which is determining whether this date is a holiday, we don't want that intermingled with something that accesses external resources. Split those apart. Now you can test your business logic without having to deal with the fact that it's going off and touching something external like the system clock. Another example of external resources, and by the way, this idea of avoiding external resources is really probably the fundamental thing that I've found that makes code hard to test. I'd say easily 80, maybe more % of the code that I find that is hard to test is because it's doing something with external access, either going off to some web server, an API somewhere, or it's accessing system files, or it's going off and touching a database, or whatever it is. That seems to be one of the key things that makes it hard to test, because they've intermixed that with the decision of what to be done. So here's an example of a routine that does some complex action. You hand it some input, and it goes off and it munges the database, it writes some files into the file system, it goes off and it talks to some external API on the web, whatever it is. How do you test that? Because now you've got to go maybe query a bunch of stuff out of your database, or you've got to go inspect the file system to make sure that the change was right, or it's complicated. It makes the testing difficult. Instead, you could split that into two pieces. So now you have a routine in the bottom here, make complex decision. It doesn't do anything. You give it the same input, and it returns to you a list of the things that need to be done as a result of that input, but doesn't actually do any of them. So it is pure business logic. It makes decisions, but it doesn't take any actions. And then you have another routine that you hand it the list and say, now go do these things. Okay, I think it's pretty clear that the first one's going to be easier to test. You give it some input, and you use an is deeply or whatever on the array that's returned, and you just verify that, yeah, it made the right decisions. Now, this is kind of a contrived example. It's really probably not the best way to deal with it. It's a possibility, but there are other techniques that accomplish the same end result of separating the decision of what to do from actually doing it. So, for example, if you're in object-oriented programming, your new constructor might allow you to pass in various objects that do system or external access for you. These are things that in your test you can mock. In the real application, maybe you don't pass these things in and you have some default, like a database handle or whatever, whatever access to some external resource. But in the test, you can override that by passing in mocked objects that allow you to control that, and so that it's still making the decision and doing the action, but it's doing the action is really just calling one of these objects saying, please modify the database in this way, please do this to the file system. And then in the test, you write a mock object that doesn't actually modify the database or modify the file system. It just records the fact that, oh, he requested me to do this. And then in your test, you verify that the right things were requested. Okay, so the key here is separate the decision from the action. That's the key. Another issue is global variables. We've all been told that global variables are bad, we shouldn't do that. Sometimes you have to. Sometimes you can't avoid it. But think about it. Do you really need that global variable? Maybe it should be, if you're doing object-oriented programming, maybe it shouldn't be global, maybe it should be in the object. There's a variety of other solutions to that that avoid the external variables. And when you reasonably can, you should avoid external global variables. The problems that it causes, and I'm sure you've all seen these, is a test that fails when you run it as part of the test suite, but then you run it in isolation and it works. That's really hard to debug. I hate that when that happens. And frequently, one of the causes is those global variables. Not always, but that's a common cause of that. Or you change the order of your tests and suddenly they stop passing. Oh, that's bad. Quite frequently, it's global variables. And remember that if you're doing object-oriented programming, a singleton is really just a kind of global variable. So that doesn't mean they're bad, but think about it. Do you really need that singleton? Is there a better way of doing it? So consider that. Another thing is caches. Now, if you're accessing some database and you keep hitting the database over and over with the exact same query over and over, maybe you need a cache to improve performance. But that cache is a global variable. It's going to cause these kinds of problems if you don't deal with it correctly. So think about it. If you have to have that cache, maybe you don't need the cache. Maybe your system performs well enough without it. Don't prematurely optimize. Wait and see. Does it perform well? Oh, it doesn't perform well enough. Okay, I need that cache. But when you implement the cache, make sure that there's some mechanism that you can reset that cache so that when you're testing the code, you have a way of resetting the test and making sure that the logic is working correctly. Another thing that I've seen in a lot of examples, especially in web-like programming, you'll have a routine, for example, here that determines whether or not this person you're dealing with is an employee versus, say, a customer. And all it's really doing is it's looking at the email address, and is it at mycompany.com, or is it something else? Well, hey, it's a web program. You pass in the context, and it pulls out the email address, and it figures this out. Or you could simply pass the email address, which is easier to test. Okay. If I have to, in my test, if I have to go create a context object, stick the email address in there, pass it in there, that's just some extra steps. It'd be simpler if I could just simply pass the email address. That will make the test easier. Now, I agree, it's not a great deal of extra work, but if it really doesn't need anything else, why are you passing a context? just pass the email address. So these are things that will make your tests easier and more readable. The shorter they are, the more concise they are, the easier your tests are to understand and maintain. Therefore, your testing is better. So the next thing is do one thing and do it well. Again, a general principle touches a lot of different areas. If you write a description of what this method or class or whatever is about, do you have to use the word and? If you have to use the word and, you can't describe it without using the word and. That's a red flag that maybe you're really doing two things. Maybe this should really be two methods or two classes or two whatever. Think about that. Now, not always, but quite frequently that and in your description is the red flag that says, this is really something that should be split apart into two separate things. Okay, by isolating that, that will make it easier to test because you're only testing one thing instead of two things together. Make sure that all of your business logic is collected into one place. So don't have multiple logic scattered around different places that this modifies the table over here and you've got some other logic over here that modifies the same table and some other logic. Pull that together into one place. Make one class, for example, that deals with that table or a collection of tables in the database, and nothing but that class touches those tables. It's all isolated into one spot. If you have a bug, you know exactly where to go. That's the spot because it's the only place that touches it. Do you have duplication of code? So is that code either the same algorithm or a very similar algorithm appearing somewhere else? I don't know how many times I've looked at some code and I think, gee, I've seen that loop before. Oh yeah, it was over. Oh yeah, it's almost, oh, they changed one variable. Oh yeah, it's the same loop, the same logic. They just cut and pasted and stuck it over here and made a little tweak to it. Bad idea. Pull that out, abstract it out, make something more generic that both of these places can call and reduce that down to one place to do that. So an example, one of the places where I've seen this come up is, for example, a web app that has some cron jobs or batch jobs that assist it, that run daily to do whatever database operations need to be done on a daily basis. And the web app goes and it modifies the database in some particular way, and the cron job or the batch job goes in at 2 o'clock in the morning, and it has basically the same kind of logic to access that same table or set of tables in the database. It'd be much better if you instead create a class that manages that part of the database, and the web app calls it, the cron job or the batch job calls it. Now you've collected it into one place. Now you have one place to test. Okay. So in summary, as you're writing code, assuming you've not already written the test, as you're writing that code, think about the test. That's the number one takeaway here, is think about the test. And most of the things that I've discussed here will just occur to you. They did to me. I've been doing this for 20 plus years, and a lot of these things that I've read in those papers, that slide I put up with all the buzzwords on it, a lot of that stuff just occurred to me because, well, I thought about the test and I realized, gee, if I do this, it's going to be bad. And so really most of those things on that page with all the buzzwords, most of those things really aren't earth-shaking, oh, wow, that's great, I would have never thought. Now, you would have thought of this. These are things that are just obvious if you think about your testing as you're writing the code. So that's why that's the most important concept here. Think about your testing, and most of this stuff will just be obvious to you. Use the pod to document your user interface. The pod is the documentation for the external user. The people that are developing and maintaining that code, that's what your comments are for, because they're in there, they're in the source code file, they see those comments, that's for them. Pod should not discuss your implementation details. It should only tell the things that the user needs to know to use your code. be sure that you separate black box and white box testing. So maybe I write a test, a .t file, and it has some black box stuff here and some white box stuff here and some black box. Is that good? What problems will that cause? Somebody?
People often look at tests to figure out, when it's under documented, as a second documentation, how do I even work this? And if you see the white box, they see
Okay.
that, I don't have to sort this, you already did, as you mentioned.
Okay, so the point brought out is that some people will look at the test as an addition to the documentation of how to use it, as examples. And so they may then discover things that you don't really want them to know about your test. And it must have gone by on a slide and I didn't talk about it. But one of the things that I like to do is when I write my documentation, the first thing I write is the synopsis. And the synopsis is that section where you say, okay, use my module, whatever it is, and you call this constructor, you call it whatever. You give an example of how to use my code. So you're really showing use cases of your code. You're giving concrete examples of call it with these two parameters, and then you put it in a loop and you do this, and you're showing concrete, this is how my code works. Write that before you write the code. In other words, decide, gee, as a user, I want to be able to call the constructor and tell it this, and then I want to be able to call this method on it and get this back. That drives the design of your code. And so that's a key part of writing the documentation, making sure that it's thorough. List your use cases, at least the main use cases, in that synopsis section. And so that now your pod is thorough, you have examples, you're not forcing them to go to tests to find examples of how to use it. You've put those examples right there in the synopsis. Everything they need is in the pod. You're not forcing them to go look at the source code. All right, so getting back to the black box test and the white box test intermingled together. So the thing I was looking for is if that test, that .t file fails, and I'm fixing this bug, and I say, yeah, that's because I changed this loop and it doesn't, and I got to go fix that test to make it pass again. And I inadvertently change one of the black box sections of that test because it's not clear to me which is black box and which is white box. You need to separate those. I think that you really need to have a separate .t file for your black box and a separate .t file for your white box. Maybe even separate directories. But certainly keep them clear, keep them separated. Maybe you need a naming scheme that clearly says this is black box, this is white box. So when I'm fixing a bug and this test fails and I see it's black box, I can't just go change the test. I've got to figure out why my code is failing now. Because if I change that test, I'm breaking backward compatibility. So it's important that you keep black box and white box separated for that very reason. So that as a developer, when I'm fixing bugs, adding new features, I know that, that failed, that's not allowed. I cannot let that fail. My code's wrong now. This white box test failed, that's okay. I changed my algorithm, I'll just go fix the test to pass now. Okay, so it's very important to keep those separated. So the black box is the key to supportable code that does not break backward compatibility when you make changes. And keeping that separate is very important. So, any questions? I'm a little bit ahead of schedule here. Yes?
I usually find that when you write a mock to help a test, now you end up with two tests. So, my question is, if you feel the need to write a mock to mock a service, how do you know that your mock service is right?
Okay.
What kind of checks and balances?
So the question is, I need to write a mock for some external service because I want my test to not actually go off and hit that external thing, whatever it is. How do I know that my mock is mocking correctly? Well, I don't know that there's really any magic bullets that solve that problem, but that's where integration tests come in. because an integration test is now going to run with the real service, and if it behaves differently from your test, that's one way of detecting it. You could always write a test for your mock service. That might or might not be easy. I'm not sure there's really any magic bullets. Anybody else have ideas of things they've done?
I would say in that case, you've got to test empirically, basically, just say, okay, I'm going to test these particular functions of this particular DBI call, or whatever the live test is. In my case, I would then have those outputs saved into some static file or something, and then you would then test against that value. You would mock those calls against that value.
So you're saying you would use the actual service and record what you got back from it and use that to generate your mock?
Exactly.
Okay, all right, that's a good technique.
Because
Right.
This way, when you're doing your test, it should never go up to, the GBI, the web, whatever. It's going to hit that mock.
Right.
It's that mock, that's all you want is one that's valuable.
Okay, all right, that's good. Yes.
There is a controversy in one of your examples. Example about is employee. You say, okay, if you need only email to check it, that's enough possibility. Okay, but doesn't it limit us in implementation? I mean, we have, let's say, we started the project. There was one requirement: how to define whether it's employee or not. In a year, they change the requirement. We need to do it another way. But the function is employee.
Right, okay. So the point here is that go ahead.
The point is how to avoid this kind of limitations.
Right, okay. So what he's talking about is my example of passing in an email address versus a context into the decision of is this an employee or not. And what he's saying is that, yes, today maybe you're making the decision based on the email address, but later you decide, no, I need a more complex, more secure decision that's based on more than just the email, and now I really need the context.
One thing I will say, okay, and this is actually a part of black box text because it's API. So it means we would need to change a black box test.
Yes. Right. So if that employee is part of your black box testing, it's part of your defined interface, and you define it to only accept the email address, now you're locked in. You can't access other things to make the decision. So yes, I agree. I'm not saying that technique is you should always pass the email address. You need to think about that. What is the future? Plan ahead is, will you ever need something more than just the email address? If there's a possibility you do need more, then you need to pass the context. Okay? It's not going to make the test that much harder. We only saved maybe 3 or 4 lines in the test by doing that. So it's a balance. You have to think about, is it better to pass the email address and now I'm locked into that's all I can make my decision on? Or is it better to pass the context and live with a few more lines in my test? I mean, it's not that big of a deal. We're just trying to make things a little bit better, but don't go so far that you actually make things hard to improve in the future because of saving a couple of lines in your test. Okay. Yes.
I would say the other alternative is that if you know one is going to be email and the other might be city or something, you make 2 different functions. And then you would pass city for is employed by city, is employed by email.
You see, the point is that it's opening some level of abstraction where you don't care about the data you analyze. Okay, you cannot even be sure what kind of data is it. I mean, employee is just a particular example. But in real life, for example, you write the device handler, and then under the device handlers, you have a couple of drivers, different kind of devices. And they might be too different. You might not know what kind of device just look at abstraction. And is it capable of managing its own frequency, for example? Because no idea how this data is going to be
You make an
determined.
abstract object and then bring
Yes,
that down.
yes,
And whatever
and-
changes underneath, we don't care.
Yeah, but what I mean here is that at this level of abstraction, it would be pretty different to simplify tests.
Yeah.
This way. That's just the point. I just want to point out that life often is more complicated and it's nothing that has to be taken.
Right. So I think one of the key things here is the abstraction.
Yes.
if this is your user interface, you don't want the user knowing that, you don't want the external user to know that you're basing this on the email address. And for that user interface, you want to pass the context because you don't want them to know how you're making the decision. That's implementation detail. But one thing I could say is that maybe the external user interface is something that takes a context, but then inside that routine, you call a method that you just pass it the email address, and now you can test that simply. Now, of course, that's a one-line regex, but so that's probably not a good example, but maybe something a bit more complex where you need one item or two items out of that context. Maybe you call some other routine that you pass those one or two items, and it makes, it's just a dozen lines of code, and now that's easier to test. Just some thoughts.
6 or half
Yeah.
dozen.
Yeah, I mean, maybe that's not any better. Maybe that's more complexity, and it's just,
So your top one is a black test, and the bottom one is a white test.
right, right. So, yes.
You mentioned that the claims in the documentation are a good way to figure out the black box test that need to be performed. Is there any way to find a list of productive white box tests?
Well, you could do the same thing with your comments if you've been thorough in writing your comments. And one other thing I wanted to mention is I wrote, because I've done this repeatedly of taking the black box, the documentation, enumerating all the claims and writing a test for each one of those. I just released a module to CPAN called doc claims, DOC claims. And what it does is it helps you manage this checklist of all the things that you've documented and make sure that you get them into your tests. And the big thing that it helps you with is that if you, in maintenance mode, you're going to make changes, you're going to add new features or whatever, you're going to change your documentation, and now suddenly you have a new paragraph that makes 3 more claims. Well, you want to make sure you get those over into your black box test. And so this helps you manage that. Basically what it does is it takes the documentation, the pod out of your code, and you put that into the .t file. And it, in essence, diffs the two to make sure that they're in sync, so that if you make some changes over here in the code and you document with a new paragraph this new feature, and you fail to write a test for that, now this diff is going to tell you, oh, you need to go fix your .t file because things don't match anymore. It's still a work in progress. There's some issues with it, but it's out there. If you're interested in this, take a look at it. Tell me the things that are wrong. Tell me the things that I'm not covering yet. DOC claims is the name of the module. Test : doc claims. So, like I said, it's not perfect. It's a work in progress at this point. I call it version 0.001. Yeah. Oh, it's definitely less than 1.0. One of the big things is how do you've got a copy of the pod over here and a copy of the pod over here. How do you manage that difference? And it'd be nice if I could just automatically copy things. And so I'm working on some utility scripts that help with that, and I haven't figured that out yet, but it's a work in progress. Yes?
You did a comparison between sending a path to a file and sending the contents of a file.
Right.
Another possibility is to send a file handle, because we know in Perl you can open a string as a file.
Right.
So if you use that as your interface, that's another way to test it.
Okay, so what he brought it out is that in the example where I was talking about passing the path to the file versus the contents, you could also pass a handle, which in Perl, in your test, you could open up a string as your file, and now you don't have to deal with temporary files in the test temp directory, which would make it a little bit easier. So that's another possibility. So one other thing I want to close with is that if this topic really interests you and you're excited about this kind of thing, we would love to have you at Grant Street. We have a table right out here. Right. Thank you.